In this video, we're going to take a look at 20 different practice problems dealing with the SAT or the ACT. Real quick before we get started, if you'd like to download a free copy of this blank PDF, you can find a link to that below, where you can also find the annotated answer key PDF as well. As always, I encourage you to grab some paper, something to write with, and let's do some math together. For number 1, it says to increase the mean of 5 numbers by 3, by how much would the sum of the 5 numbers need to increase? To start, we want to make sure we know that the word mean means average. And so what I would do here is just create 5 quick variables to represent the 5 numbers. Now remember, when you're taking the average of 5 numbers, you're going to add those 5 numbers up, then divide by the number of numbers, which in this case would be 5. And so we know the average is going to be trying to increase by 3. So let's just say we don't know what the average is, but we're going to use x to represent the average. Alright, so if we took the average of these 5 numbers of A, B, C, D, and E, so we took those and found the sum, then divided by 5, we would get x, which is the average. So let's go ahead and see if we go ahead and multiply both sides by 5 here, let's see what's going to happen. So if we multiply both sides by 5, the 5s are going to go ahead and cross cancel on the left side. So we know that the sum of these 5 numbers has to be equal to 5x. So from this, we know that we could represent that the sum of these 5 numbers is going to be equal to 5x. And so at this point, we know that the sum of these 5 numbers is equal to 5x. All right, so if the original sum is 5x and they wanted us to increase the mean by 3, let's go ahead and look at that original equation where we got the average, which is x. Let's see, if we wanted to increase the average by 3, let's see what would happen to the sum of those 5 numbers. Now, if we go ahead and just take this whole thing and multiply this by 5 again, like we did earlier. Again, these 5s are going to go ahead and cross cancel. And you're going to get that the sum of those 5 numbers is going to be equal to, and if we distribute that 5 to this x plus 3 on the right side, that's going to be 5x plus 15. So let's go ahead and write 5x plus 15. And so you can see the sum of these 5 numbers, while it used to be 5x, would now have to be 5x plus 15. This would be the new sum, and you can see that it is going to be 15 more than the original sum. And so to get the average to go up by 3, we would have to get the sum of the numbers to go up by 15. All right, here is number 2. In number 2, it says if w times x cubed times y to the 4th power is greater than 0, which of the following products must be positive? All right, so it looks like we have 3 bases here. We have w to the 1st power, we also have x to the 3rd power, and then we have y to the 4th power. While these first 2 bases are raised to odd powers, notice how the 3rd base here is raised to an even power. Now, w to the 1st power could be positive or negative. We actually don't know because it depends on the value of w. If w is going to be a positive value, then a positive value raised to the 1st power will be positive, and if it's a negative value, then a negative number to the 1st power would be negative. So w to the 1st power could be positive or negative. We know it can't be 0 because if any of these bases were 0, then this whole product would not be greater than 0. Similarly, this x to the 3rd power can also be positive or negative because we're raising this to an odd power. So a positive to an odd power is positive, and a negative to an odd power will be negative. Now, differently than the first 2 bases, this y to the 4th power must be positive no matter what, just because if y was a negative number to the 4th power would be positive, and if y was a positive number to the 4th power would also be positive 100% of the time. So if we know that this y to the 4th power must be positive no matter what y is, we actually don't really need to focus on that part of the expression very much. We can actually go ahead and take our attention and focus more on this w times x to the 3rd power. Remember that w to the 1st power could be positive or negative, and x to the 3rd power could also be positive or negative. However, if we can go ahead and guarantee that their product here is going to be positive, then what is a positive multiplied by a positive going to be? Well, it's going to definitely be greater than 0 because it's going to be positive. Now, if w times x to the 3rd power is equal to a negative number, a negative times a positive would equal negative, and that's not going to be greater than 0. And so when the question says which of the following of these products must be positive, we know it's going to be A, which is going to be w times x. If we can guarantee that w times x is a positive value, then we can also guarantee that w times x to the 3rd power is also going to be a positive value. Now, in order for this product to definitely be positive, keep in mind of a couple things here. That would only happen if w was a negative number while x was also a negative number. If that was the case, that would make a positive value if you multiply negative times a negative. And the other case would be if w is a positive value and if x was also a positive value, because a positive times a positive is always going to be a positive as well. So if we're going to guarantee one product that has to be positive, we'd have to be guaranteeing that wx is positive. If that's true, then if you plug that into each of these expressions, w times x to the third power, that'll guarantee be positive, and then a positive multiplied by this one, which we know is positive, will be greater than 0. Here's number 3. For number 3, we have after Oliver spent 90% of his vacation money, $100 remained. How much vacation money did he originally have? So we know that 90% of the money was spent, which means that 10% of the money remains. So this 10% we know is going to be $100. We can go to set this up. We know 10% means 10 out of 100 as a ratio per 100, and that 10% that remains is $100 out of the total. We don't know the total just yet, but we can go ahead and solve it in just a moment. We can go ahead and set up this proportion though. If we go ahead and just use equivalent ratios, we can see that 10 multiplied by 10 is 100. So then 100 multiplied by 10 must be equal to x. If we do that, 100 times 10 does equal 1,000, so we can say that x is equal to 1,000. Therefore, we know that Oliver originally had $1,000 before he spent 90% of his vacation money. Moving on to number 4, we see that we need to simplify the following expression, and it looks like we have a radical expression here. So when we see this expression, what we're going to do is just go ahead and expand it to make it extra clear. But this means 5 times the square root of 3 multiplied by another one of these 5 times the square root of 3. So it looks like everything is really just being multiplied together here, right? So we really have 5 multiplied by the square root of 3 multiplied by 5 multiplied by the square root of 3. If you want to, then you can just go ahead and turn things around, just multiply in any order here. So 5 multiplied by 5, we know that's going to be 25. Okay, and then if we go ahead and just take this square root of 3 times the square root of 3, that's going to be equal to the square root of 9, right? So you can see where each of these pieces comes from here. So we have 5 times 5, that is where that 25 is. And then we have the root 3 times root 3, which is root 9. Now, this 25 is going to stay the same. That root 9, the square root of 9 is just 3. So 25 times 3, we can say, is 75. This would be the most simplified way to write that expression. All right, here is number 5. In number 5, it says, what is the smallest positive integer that is divisible by 3, 5, and 6 with no remainders? Now, while there's a few different ways we can go about this, it does say look for the smallest integer that is divisible by all 3 of those numbers. So I would just look at the smallest answer choice first, which is 15, and notice how the answer choices are in order from least to greatest. So we can just kind of go in order here. Now 15 does divide 3 and 5 evenly, but not 6 because it's not an even number. If we go on to 30, 30 does divide by 3 and 5 and also divides by 6. So from that, I would actually just look at those answer choices and go straight for them. However, if you wanted a strategy that'll work in case the numbers aren't so small or isn't as clear, you can just use this strategy for the least common multiple. You can take 3, 5, and 6. Some people refer this as the ladder method. You just put all the numbers side by side. Then you try to see if there's a common factor that goes into all 3. Looks like they're relatively prime, so their GCF is 1. So they just gonna go and say that 1 goes into all these numbers 3, 5, and 6 times. But after you're done seeing what goes into all 3 numbers, you then see if something goes into 2 of the numbers. So 3 and 5 are relatively prime, their GCF is 1. 5 and 6 are also relatively prime, their GCF is 1. However, 3 and 6 here, their GCF is 3. So you can go ahead and just pull out a GCF of just 2 of the numbers after you're done trying to find a GCF for all 3 numbers. 3 goes into 3 one time. 3 didn't go into 5, we just kind of ignored that one. And 3 goes into that 6 2 times. Once everything is relatively prime with just 2 numbers, then you can't do anything else. So 1 and 5 are relatively prime, 5 and 2 are relatively prime, and then 1 and 2 are relatively prime. Then we're all done here. So to find the LCM or least common multiple, you can just look at these numbers on the outside and multiply them together. So 1 times 3 is 3, times the 1 is still going to be 3, times the 5 is going to be 15, times the 2 here is going to be 30. So you can use this method for the LCM as well. All right, moving on. Here is number 6. For number 6, it says, what is the sum of the prime factors of the number 330? So first, I would just go ahead and start writing prime factorization for this. So 330, we can break this up into 10 times 33, make a little factor tree here. 10 will break up nicely into 5 times 2. These are both prime numbers, so I'm just going to go ahead and circle them. They can't be broken down anymore. And then for 33, I would say this is going to be 3 times 11. This 3 is a prime number, and 11 is also prime. So now that we have all the prime factors, it says find the sum of them. The sum of these prime factors is just going to be taking 5 plus 2 plus 3 plus 11. If you go and say 5 plus 2, that is going to be 7. 7 plus 3 is 10, plus this 11 is going to be 21. And so the sum of all the prime factors of 330 is going to be 21. Here's number 7. In number 7, it says, in the standard xy coordinate plane, a line passes through the points 1, -2 and 5, 10. It says, at which point does the line cross the y-axis? All right, so for this one, I'm just going to go ahead and make a rough sketch here. So one of the points is going to be at 1, -2. We know that's going to be down in quadrant 4. And then the other point is going to be at 5, 10, which is going to be in quadrant 1. So maybe something like up here. And so we have to basically figure out the equation of this line. So we know it's going to have a straight line here. And they're wondering when does it cross the y-axis, and the y-axis is going to be right over here. All right, so drawing a line through these 2 points, it would look something like this. So we're basically just trying to find this location here as to where it crosses that y-axis. So it looks like it's going to be a negative value, but let's go ahead and see if we can find out the exact value. All right, so first we should find the rate of change, or the slope of this line. If we go ahead and just see how much vertical change we have here, it looks like our lowest point that we have is at -2 and the highest point is at 10. So it looks like our vertical change is going to be 12. So 2 plus 10 is going to be 12. And then if we take a look at our horizontal change here, that's going to be from here to here. That looks like it's going from 1 to 5, so that's going to be a distance of 4. So if we're trying to figure out what our slope here is, or our rate of change, our slope, or we call this m, is going to be our rise over run. So vertical change, the ratio of the vertical change to a horizontal change, that's going to be 12 to 4. So our rate of change here is going to be 3. That's our unit rate of change. So we know this is a straight line. So what is our equation for straight lines that we like to use? Most famously, we have y is equal to m, or the rate of change, multiplied by x plus b. And remember, b is really just our starting value, or constant, or where it crosses that y-axis. In this case, we know that m is equal to 3, so we can say y is equal to 3. That's our coefficient, multiplied by x, and then we're going to go ahead and add on b afterwards. So to find this b, we really just need to plug in a value for x and y that we know is going to be on the line. Then we can solve for b. Then we're going to have our point. Looks like we have an x and a y here. We also have an x and a y here. So either one you want to choose is going to be fine. I'm going to go ahead and say that I'm going to use this 5, 10, but totally up to you if you want to use the other ones. So y is going to be 10. And then I'm going to say that's going to be equal to 3 multiplied by x. In this case, it's going to be 5. So 3 times 5. Then we'll go ahead and add b. Now, 3 times 5 is 15, so I'm going to say 10 is equal to 15 plus b. If you take away 15 from both sides, we're going to say b is equal to -5. So when the question says, at what point does the line cross the y-axis, we can say the equation at least is going to be y is equal to 3 times x, and then it's going to be plus -5 or just -5. Now, while that is the equation of this line, we know that this line is going to cross the y-axis at 0, -5 down here. All right, here is number 8. In number 8, it says if p and q are positive integers, and 6 times p times q to the 4th power and 12 times p squared times q squared have the greatest common factor of 1050, then which is a possible value for the sum of p and q? All right, so we have these two monomials here, and we're going to go ahead and find the greatest common factor, or the GCF. And we can go ahead and do that by using the ladder method if you'd like to. But first, I'm going to start by finding just the GCF, I guess, of our coefficients. So the greatest number that goes into 6 and 12 is going to be 6. If we go ahead and take out a 6 here, then 6 divided by 6 is 1. We're going to be left with p times q to the 4th power. 6 goes into 12 2 times, so we can say we have 2 p to the 2nd power and q to the 2nd power. All right, so we took care of the coefficients. I'm just going to actually do one base at a time here. Now looking at the p's, looks like we have just p to the 1st power here and p to the 2nd power. So in common, they both have a factor of p. So if we factor out a p, we're going to be left with q to the 4th power, and then 2 times p times q to the 2nd power. Okay. And then finally, if we go ahead and do this one more time to take care of the q's, looks like this one has 4 q's multiplied together. This one has 2 q's multiplied together. So I think it's safe to say in common, they have 2 of these q's that are multiplied together. So q to the 2nd power times q to the 2nd power is q to the 4th power. And then we're still left with 2p and no more q's over here. All right, so keep in mind that the 6 is what they had in common, the p is what they had in common, and these 2 q's are what they had in common. So if you go ahead and multiply those together, we can see here that the GCF of these monomials is going to be 6 times p times q to the second power. But keep in mind that we're also told that the GCF is also going to be 1050. So if that's true, we can go ahead and say that this 6 times p times q squared is equal to 1050, right? That must be true if they both represent that GCF. So if we go ahead and divide both sides by 6, then we're going to find that p times q to the second power is equal to 75. And if you go ahead and break down this 75 into its prime factorization, it's going to be 3 multiplied by 5 times 5. Right? Just because 25 times 3 is 75 and 25 breaks into 5 and 5. And that kind of makes sense because if you take a look here, that's the same thing as p times q, where you can see here that maybe this, let me go ahead and highlight these. You can see this 3 would match this p really nicely, and then these 5s as factors would match these q's nicely. So from that, I think we can say that p is equal to 3 and q would be equal to 5. So if we're looking at the sum of p and q, if we know that p is going to be equal to 3 and q is going to be equal to 5, then 3 plus 5 is going to get us an answer of 8. And so for this problem, I would go with answer choice B. All right, here is number 9. In number 9, we see that if w to the 6th power times t to the 5th power divided by m to the 9th power is greater than 0, then which of the following must be true? Now, if we take a look at each of these bases, notice the powers that they have. So this one has an exponent that's even, we have an odd and another odd one here. Just like earlier, if you raise a negative or a positive number to an even exponent, it's going to be positive no matter what. So w to the 6th power has to be positive no matter what. However, t to the 5th power could be positive or negative. It depends if t is negative. If t is negative, then we're going to get a negative value. If t is positive, we'll get a positive value. Now, because this m is also raised to an odd power of 9, it's going to have the same effect where it could be positive or negative. So if we know that w to the 6th power is positive no matter what, then we don't really have to worry about that. That's not a factor here. And we're trying to guarantee that this whole expression is going to be greater than 0 or positive, so we really just have to focus in on this t to the 5th power over this m to the 9th power. If we can somehow guarantee that this t to the 5th power over this m to the 9th power is going to be positive or greater than 0, then this whole thing on the left is going to be greater than 0 when we multiply it all together. If t was negative and m was positive, this wouldn't be true because we would get a negative. If t is positive and m is negative, it also wouldn't be true. However, if t and m are both negative, then a negative divided negative will be positive. That would work. Or if t and m were both positive, that would work just because a positive divided by a positive is also going to be positive. Now, the rules for dividing and the rules for multiplying for integers are the same. So if we know that both of these have to either be negative or both have to be positive, then we know that E has to be our answer here. If we can guarantee that this is going to be true, then we can go ahead and guarantee that this t to the 5th power over m to the 9th power will also be positive. If that's true, then this positive value of w to the 6th power multiplied by the rest of this, which is positive, will guarantee us to get a value that is positive. All right, for number 10, it looks like we are going to go ahead and see if we can find a fraction that is located exactly halfway between 3/8 and 4/5 on a number line. Now, there's a few ways we could go about doing this, but if we know it's exactly halfway in between them, you can think about it being our midpoint or the average of these two fractions. So to find the average of these two fractions, I'm just going to actually just add the two fractions and then divide that by 2. Right? Now, if you add these two fractions, we need some common denominators here. So I'm going to go ahead and multiply this by their factors that help get us our GCF. So because they're relatively prime, I'm going to multiply by each other. So this is going to be the same thing as 15 over 40 plus 32 over 40. And then we're going to go ahead and take that whole thing and divide by 2. Now 15 plus 32, that's going to be equal to 47, so it's going to be 47 over 40, and we're going to go ahead and divide that by 2. Now, dividing by 2, we can just write divided by 2 over 1. So if we go ahead and rewrite this as a multiplication problem, this would be 47 over 40 multiplied by 1 over 2. And if we go ahead and multiply these two fractions together, we're going to see that this is going to be equal to 47 over 80. 47/80 would be exactly between 3/8 and 4/5 on a number line. Here's number 11. For For number 11, 1 square inch on the average pizza contains 50 calories. Claire bakes a 12-inch diameter pizza and cuts it into 8 equal slices. If her mom eats 3 slices and Claire only eats 2, approximately how many more calories did Claire's mom eat than she did to the nearest hundreds? Remember that the area of a circle can be determined by using the formula A is equal to pi r squared, where pi is about 3.14. Alright, so to start, we should figure out what the area of this circle or pizza is going to be. So we know that we have this 12-inch diameter pizza. If that's true, and we know that the diameter of this pizza is going to be 12, then the radius is just half of that. So the radius must be equal to 6. If we take that information and plug it into our formula, where the area is going to be equal to pi times r squared, we can say that this is going to be equal to pi multiplied by this 6 squared. Now 6 squared is 36, so we know the area of this pizza is going to be 36 multiplied by whatever pi is, which is about 3.14. So 36 times 3.14 we can say is about 113.04. That would be the area of this pizza. That's going to be in square inches. Now keep in mind that we know that each of these square inches is going to be representing 50 calories. That's how much it's going to be for each one. So if we go ahead and take this 113.04, that's how many square inches we have. We multiply that by 50 because there's 50 calories in each of those square inches. Then 113.04 multiplied by 50 calories per each of those square inches is going to get us this approximate value of 5,650, and that's going to be the number of calories that we have on this entire pizza. Next, we know that her mom is going to be eating 3/8 of the slices, so she's going to be eating 3/8 of all those calories. So you can do 3/8 multiplied by this 5,650, so we can figure out how many calories she's eating. And we also can figure out for Claire, Claire's eating 2/8 of the slices, so you can find 2/8 of that amount of calories of 5,650. That'll tell us how many calories she's eating, right? Or you can go straight into just finding the difference right away of how much they are eating differently, because we know the amount of slices that they're eating. So the difference here is really just of 1/8. So if you don't really feel like doing all that work above, you can just do 1/8 of 5,650, and that'll be the difference of calories that they're going to be eating, right? You totally can find out how many calories the mom eats and how much Claire eats and subtract, or you can just do this. So if you go ahead and multiply these together, I'm using a calculator, so feel free to use one as well. We're getting 706.25. So that's the difference in calories that we are seeing here. And the directions do say round to the nearest hundreds. So we would go ahead and say that to the nearest hundred, this would be 700 calories difference. This would be our answer, rounded to the nearest hundreds place. In number 12, a rectangle is 4 times as long as it is wide. If the width of the rectangle is 4.5 centimeters, what is the rectangle's area in square centimeters? All right, so for the width here, we know the width is going to be 4.5 centimeters. We can go ahead and write 4.5 centimeters. Now the length here we're told is going to be 4 times longer. So it's going to be whatever, 4.5 centimeters multiplied by 4, because we know it's going to be 4 times longer. So if we go ahead and figure out what that new length is going to be, then 4.5 times 4, that's going to be 18 centimeters, right? So that's actually how long that length is going to be. And so we find out the area of this rectangle is just going to be length multiplied by width. Now the length in this case we know is 18 centimeters, and the width we know is going to be 4.5 centimeters. So if we go ahead and multiply 18 times 4.5, go ahead and plug that into a calculator. 18 times 4.5, that's going to be 81. And so the area of this rectangle would be 81 square centimeters. All right, here is number 13. In number 13, let's find the product of this 3 thousandths and this 49 thousandths, and we're going to write that in scientific notation. Now, what we can do here to speed up the process instead of multiplying them is just take this 0.003, and remember that's the same thing as 3 multiplied by 10 raised to the negative third power if we write that in scientific notation. And if you take this 0.049, if you want to write that in scientific notation, that's going to be 4.9 multiplied by 10 to the negative second power. All right, now if we're going to go ahead and just multiply these two together, what you can do is just multiply these two decimals together. So we multiply 3 multiplied by this 4.9, right? So multiplying 3 times 4.9, that's going to be 14.7 all right? And then if you go ahead, so that's what you get when you multiply 3 times 4.9, we get 14.7. And if we multiply this 10 to the negative third times 10 to the negative second, that's going to be 10 to the negative fifth power, all right? So this right here almost looks like our answer to the product here in scientific notation, but keep in mind, for scientific notation, you can only have one whole number, and we have 2 here, right? So let's go ahead and just divide this 14.7 by 10, so it's going to be 1.47. So if we go ahead and divided that by 10, we'd have to multiply 10 to the negative fifth by 10, so it's going to be times 10 to the negative fourth power. So again, I would just rewrite each of these factors in scientific notation. So 3 times 4.9, that's where this 14.7 is coming from here. And then if we go ahead and take the 10 to the negative third power and 10 to the negative second power, multiply them together, you get 10 to the negative fifth power. Keep in mind, scientific notation should have one whole number to the left of the decimal. And so we just had to go ahead and divide it by 10 here, but multiply this one by 10 here to balance it out. So in scientific notation, the product of 0.003 and 0.049 is 1.47 times 10 to the negative fourth power. All right, for number 14, let's go ahead and find the area of a quadrilateral that has the coordinates of negative 3, 5, 8, 5, 5, negative 2, and negative 1, negative 2. All right, so just so we can visualize this a little bit better, negative 3, 5 would be maybe somewhere here in quadrant 2. 8, 5 would be over here in quadrant 1. 5, negative 2 would be somewhere over here. 5, negative 2 would be somewhere in quadrant 4, which would be down here. And then we have this last point of negative 1, negative 2, which would be maybe somewhere in quadrant 4. And then for negative 1, negative 2, that looks like it'd be somewhere over here in quadrant 3. All right, so a rough sketch here would look something like this, where we have these 2 lines that are, it looks like they're parallel to each other because they're both horizontal. And then we have these diagonal lines here that we can draw, and it looks like we have a trapezoid. And so while you could use the area of a trapezoid formula, I'm just going to go ahead and break this up into some smaller shapes because I think that's probably what more people would probably do. So it looks like we have a rectangle and 2 triangles here. So if we want to figure out some of the area of these 2 shapes, well, just keep in mind, what's the highest point of this shape? The highest point looks like it's at 5, and then the lowest point looks like it's at negative 2. So if we took a look at maybe the floor and the ceiling here, we're going to be at a highest point of 5, and then we have a lowest point of negative 2. So the height here for this trapezoid, the height for all the shapes inside of it are going to be a height of 7, right? So that's going to be in common for all of them. Now, if we go ahead and take a look at each of these shapes, let's do maybe just this green triangle on the side here. We know the height of it is going to be 7, but what is its base going to be? Well, from the distance from here to here, we have to figure out what that's going to be. So this point was what? It was negative 3, 5. This point over here was negative 1, 2. So if we're finding a horizontal distance, we really just have to figure out how far is negative 1 from negative 3. Now, they're in the same quadrant, so they're really just 2 away from each other. So the base of this triangle is going to be 2. So if we want to find the area of that triangle, it's going to be base times height divided by 2. So it's going to be 2 times 7 over 2. And those 2's can cross cancel, so the area of that triangle is going to be 7. Now moving on to this rectangle in the middle, this rectangle, we can go ahead and find out the base and the height. Well, we already know the height is 7, so that's fine. So to find the base of this rectangle, that's going to be from here to here. That's going to be the horizontal distance between these 2 points. So how far is 5 from negative 1? It looks like that's going to be 6 away. So I'm going to say this is the base here. So the area of this rectangle is going to be base times height, or really just 6 times 7. So that's going to be 42. All right, finally, we have one more triangle, which is right over here. This triangle has, the height of 7 that we said earlier. We also have to find the base of the triangle, which we could use as this distance between these 2 points right here. So if we want to figure out the distance between, I guess, this point and this point, we can find we know the vertical distance, but what's the horizontal distance between them? Well, we have this point of 8, 5, and we have that point of 5, negative 2. So if we want to figure out the horizontal distance between them, how far is 8 from 5? Well, that's going to be 3. So it looks like that horizontal distance is going to be 3. So if we want to find the area of this triangle, it's going to be base times height divided by 2, or really 7 multiplied by 3 divided by 2. 7 times 3 is 21, and half of 21 is going to be 10.5. And so if you go ahead and add up this 7 and 42 and 10.5, we know that the total area of this trapezoid or quadrilateral is going to be 59.5 square units. Here is 15. In 15, it says for the square root of 3 times 7 times the square root of m times n times the square root of 7 times 5 to be an integer with m and n representing positive prime numbers, the sum of n plus n must equal which of the following? So obviously we don't have any answer choices here, so let's just ignore that last bit. And what I'm going to do to start is use a property of radicals, which is that you can go ahead and separate these bases inside here as long as we're multiplying everything together. So we have root 3 times root 7 times root m times root n times this root 7 times this root 5, right? So I'm just separating so every base has its own. And I'm going to show you why I'm going to do that. What I'll do next is just go ahead and take this root 7 and root 7 and multiply those ones together specifically. And if we do that, we're going to get root 49, right? That's if we just go ahead and multiply the ones with those same bases together. And then it looks like those are the ones that kind of have a partner there. So I'm going to go ahead and just write root 3 times this root m multiplied by root n multiplied by root 5, specifically like that. Now this root 49 just becomes 7, which is kind of nice. We know that's a nice integer here. So we got to figure out what is going to happen to the rest of these so that these also become integers, right? The whole thing needs to come out to be an integer. So if that's the case, m and n must be prime. And also we also need to know that we're going to get perfect squares. So why did 49 work out so well? Well, 49 worked out so well because the 7s were matching numbers and they have multiplied together to get a perfect square. And so you can take the square root and get 7. So what's m going to match up with? Well, either m can match up with 3 or the m can match up with 5. It doesn't really matter. And then the n could match up with 3 or the n could match up with 5. It doesn't really matter. So let's just say hypothetically that m is equal to 3 and n is equal to 5. Well, if that was the case, then we would go ahead and pair these up accordingly, right? If m was 3, then this would pair up nicely here, and you would see that that would be equal to the square root of 9. But then the square root of 9 would just be equal to 3, so then that would work out really nicely, right? And that would be an integer. And then if you took a look here, we have the square root of n and square root of 5. So if we said n was equal to 5, then 5 times 5 would be the square root of 25, which is again another perfect square, which would be nice. But the square root of 25 is just going to be 5. All right, so if that's the case, you're going to see that everything's going to multiply together here, and we're going to get an integer, which is what we're looking for. So when they ask us for the sum of m and n, you would say the sum of m and n would just be 3 plus 5. And so we can say that's going to be equal to 8. All right, for number 16, it says to the nearest foot, what is the length of a diagonal of the top of a rectangular platform that is 14 feet wide and 15 feet long? All right, so imagine we have a rectangle here, and 14 feet is going to be over here, and 15 feet is here, just because the 15 feet is a little longer. And we're being asked to find the length of this diagonal. I'm going to go ahead and call this diagonal D here. So notice that we actually have a right triangle, so we can go ahead and apply Pythagorean's theorem to go ahead and figure out the value of D. Now, Pythagorean theorem would just say that the square of the two legs is equal to the square of the hypotenuse. So we can go ahead here and say that 15 raised to the second power plus 14 raised to the second power, that must be equal to D raised to the second power. Now 15 squared is going to be 225 and 14 squared is going to be 196. So we know that that's going to be equal to whatever the diagonal is squared. Now 225 plus 196 is equal to 421. So we have 421 is equal to that diagonal raised to the second power. And so if you go ahead and take the square root of both sides, we're going to see that the diagonal length rounded to the nearest whole foot here is going to be, it's going to be about 20.5, but rounding up is going to be about 21. All right, here is 17. In 17, Emily worked one summer and earned money that she spent on some new clothes. After spending 65% of her money, Emily had $875 left. How much money did Emily earn for the summer? All right, so we know that she spent 65% of her money. So we must know that 35% of her money is left. So let's go ahead and set up a proportion here. So if she had 35% of her money left, that is as a ratio 35 to 100. And we actually needed to do this because they tell us that she had $875 left. So we know that 875 is not everything that she had in the beginning. It's what she has left. So that's going to go on top, and it's going to be out of whatever that was that she had in the beginning. Now there are different methods you can use, but I'm going to go ahead and just use cross products here. So the product of 35 and x is going to be equal to the product of 100 and 875, which is just going to be 87500. If you go ahead and take that and divide both sides by 35, 87500 divided by that 35 is going to be equal to, we can say x is equal to 2,500. And so we know that Emily had earned $2,500 for the summer. Here is 18. So in 18 here, this is supposed to say zinc. So zinc, tin, copper are used in the ratio of 2 to 3 to 4 respectively in making a certain type of engine. If each engine weighs 63 ounces, how many ounces of tin are in each engine? All right, so if we know the ratio is going to be 2 to 3 to 4, then we know that it could be 2 to 3 to 4, or it could also be like 4 to 6 to 8 if you double everything. So to keep the same ratio, what we can do in these types of problems is just say this is really just 2x to 3x to 4x, right? As long as we multiply all of them by the same thing, then we're going to keep the same ratio. So if we know the whole thing is going to be 63 ounces, then if we combine this 2x for the zinc, and then this 3x for the tin, and then the 4x for the copper, if we add up all of that amount, we know the total has to be 63 ounces, right? Now, if we add up 2 plus 3 plus 4, combine those like terms, we know that this 9x, or the total amount, is going to be 63 ounces. So then x on its own must be equal to 7. Now, if the question is asking about tin specifically, now tin is going to be that middle one. So the middle one we're talking about is the 3 or the 3x. And so if we know that x is equal to 7, then for tin specifically, we would say that for the tin, it would be 3 multiplied by 7. So we know it's going to be 21 ounces. Well, this is the answer. You could go ahead and take 7 and multiply by each of these, and then you would know that to keep this ratio, we would eventually, or essentially rather, have 14 to 21 to 28, right? Same ratio that we had in the beginning, but scaled up, and everything adds up to 63 ounces. Here's number 19. In 19, it says if x is equal to -3 and y is equal to 2, then what is the value of 2x squared minus 5xy plus y squared? So this is just an algebraic expression, and we could just go ahead and substitute in and evaluate the numerical expression following the order of operations. So if we have 2 multiplied by x, we know x is -3. Let's go ahead and just put that in parentheses, minus 5 multiplied by x, which is -3, times y, which is +2. And that's going to be plus y, which we know is 2, raised to the second power. Following the order of operations, let's just go ahead and evaluate the power first. So -3 squared is going to be 9. So we have 2 multiplied by 9, minus 5 times -3 times 2, plus, and looks like we have another power here. Let's just do both at the same time. So that's going to be 4. Moving on from here, let's go ahead and just take care of all the multiplication at once. So 2 times 9 is going to be 18. So it's going to be 18. And then minus, or it's going to be plus, right? Because I think we're going to get 2 negatives in here. So let's see, -5 times -3 is 15. 15 times 2 is going to be 30. So we're going to be adding 30 and then adding 4. So I just went ahead and took care of -5 times -3 times 2 to get 30 there. And then 18 plus 30 is going to be 48. And then 48 plus this 4 is going to be 52. And so if x was -3 and y was +2, then this algebraic expression must be equal to 52. All right, here's one final question. A straight line is graphed in the standard xy coordinate plane and goes through the points -3, 2 and 3, 6. At what coordinate does this line go through the y-axis? So this is actually a pretty similar question to one we had earlier, so I'm actually not going to draw the picture. If you want to go ahead and try to do it on your own, feel free to do so. But what I'm going to do here is figure out the slope. The slope here is going to be that rate of change. So what's the change in y between these 2 points? Well, the vertical change is going to be 6 minus 2, which is going to be 4. And the horizontal change here is going to be from -3 to 3. That's going to be 6. So the rate of change here, it looks like, is 2 to 3 ratio. That's going to be our slope here. So writing this equation, we know we generally follow this rule of y is equal to the rate of change multiplied by x plus the starting value, or our y-intercept, or b. And then we really want to find out this b value because that tells us our starting value, or where the graph goes through the y-axis every time. So we really need to just isolate this b. So what are we going to do about all of these variables? Well, first I'm just going to separate one of them, or substitute in for one of them. We know m in this problem is going to be 2 to 3 for our ratio. So I'm going to go ahead and substitute that in. But there's still 3 variables, so how do we find b? Well, we must know an x and a y, and the problem gives us 2 of them. Here's an x and a y, and we also have another x and a y. So I'm going to choose the ones that have positive values here. So I'm going to choose the 3 and a 6, and so y is equal to 6. So I'm going to say 6 is equal to 2/3 multiplied by that 3. So I'm going to multiply by 3. And then go ahead and add on b afterwards. Now, what is 2/3 times 3? That's just going to be cross-canceling and just equal 2. So 6 is going to be equal to 2 plus b, which means if you subtract both sides by 2, b would have to equal 4. So writing this equation, we can say that this is going to be y is equal to 2/3 multiplied by x plus 4. All right, this would be the equation of our line that would go through both of those points. Now, if it's going through the y-axis, then the y-axis, any point that's on the y-axis, x would have to be 0. So if you plug in 0 here, 2/3 times 0 would just be 0, and 0 plus 4 would be 4. So again, this b value is always going to tell us where the graph of a straight line crosses the y-axis. And so writing that as a coordinate, it's going to be 0, 4. And if you wanted to check this at all, you could plug in -3, 2 in for x and y, and you should get a true statement if you plug those in. If you plug in 3, 6 into x and y here as well, you'll notice that the equation will be true. And finally, you can test this 0, 4, which is definitely on the y-axis. If you plug 0 and 4 in for x and y, you're going to notice that it's also going to be true. All right, so that just about wraps up these 20 different practice problems to help you get ready for the SAT or ACT. And these are specifically some concepts that you should have covered in middle school, but maybe a little bit foggy and are just good to review. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.